bearing is always with respect to the free face. Okay, free face. So before you can choose where your bearing will be, you have to first know your free face. So with this one, here is our free face, the face that you want to blast into. So when you know your free face, then you can then choose your bearing. Okay. So the distance that is perpendicular to your free face, your free face is your bearing. Is your bearing. So we have crest bearing. That is the one that is at the crest. It's called a crest bearing, and the remaining ones are just the normal bearing. Okay. The same, we have two bearing. As you can see, we have two bearing. So the bearing is always with respect to the free face. The free face. Okay. The free face. So before you choose your bearing, you have to know your free face. And the spacing is just the distance between holes, the same row. Okay. And the spacing is perpendicular. The spacing is also perpendicular to the bearing. The spacing is perpendicular to the bearing. So that's it. So from this particular bench, you are seeing the bench that you are seeing, you can boldly say that this one, what I said, this one is it bearing or spacing? This space, because if you count the rows, so the rows on this particular bench, you have just two rows. One, just two rows. So this row we have blast holes, okay, holes on that row. And the next row you have holes in line, okay. So the distance between blast holes in the same row is the spacing. So this one is spacing in the same row. This time between blast holes in the same row is the spacing. Okay, and you know the bearing is with respect to the free face and it's perpendicular to the spacing. So this here is this one will be a bearing. Okay, here to be the bearing. The whole diameter, as I rightly said, is dependent on the bit, the drill bit. Okay. So if the bit you are using 165 millimeters drill bit to drill, you should expect your whole diameter to be 165. Okay. If you are using 115, you should expect your whole diameter to be 115. Right. So we have the whole collar. The whole collar is just the tip of the hole. Okay. The tip of the hole is called the collar, the whole collar. We know that. You know the test and tool of a bench. Okay. You know the test and tool already. And what again? Yes. You have the whole angle. So the whole angle is simply the angle that the hole you are drilling is inclined to. So if, for instance, if you are drilling you are using multiple benches, okay? If you are using multiple benches and you are drilling press plate drilling, you can decide to first drill at an angle of 70 degrees, then the remaining benches will be 90 degrees. Okay, so first from the surface, you will drill 70 degrees, then the remaining benches you will drill 90. Then if you are using triple bench, then the next bench will be 90. So assuming our bench height is 8 meters, you will draw 70 degrees inclined like this. First bench, the distance is 8 meters. That's our bench height. Then the next bench to 8 meters. But the angle will be 90. The third bench too. So our first bench, second and third bench will draw 90. So the angle that the hole is inclined, the angle is the whole angle. So is the whole angle. We have the subgrade or the subdraw. So the subdraw is simply the not low grade. Okay. So if let's say if you are using a bench height of 8 meters, you are using a bench height of 8 meters. So you can choose to add 1.5 meter subdraw. Okay. So the subdraw is just to help you minimize tools. Okay. It will help you level the surface, the surface after blasting. So if this is your 8 meter, this is so for this particular figure, this is our tool. Okay, this is our tool line. This is our tool. And this is from here to here is our 8 meter. 8 meters. We are doing 8 meters. And we want to add 1.5 meter subdraw. So that means you add 1.5 meter to the 8 meters. So you make it what? 9.5. Okay, so the total meters you will be drilling will be 9.5 meters. The 1.5 is just a subdraw. So after blasting, you can use that portion to level the surface so that we get an even floor. Okay, so that we get an even floor. Oh, are we good with the subgrade or the subdraw? So if we are drilling, um, this is our tool. Okay, this is our tool. This is our tool. This is the crest of the bench. This is the tool. And you want to draw 8 meters. All right. You want to draw 8 meters. You want to draw 8 meters. So if you blast this, you want, let's say we are, I don't want to go very deep into it so that you'll be confused. So in mining, we use reduced levels, okay? RL, we use reduced levels. Reduced levels. So if, let's say here, we are mining using you are using 8 meter bench. So if here is your 96, 96 RL, 96 meter reduced level. Here will be 88. Here will be 88 meter reduced level. You can see the distance between them is what? 8 meters. So this is the reduced level here, and this the reduced level here. So this one we will call this bench 88 bench. Okay, 88 bench, 88. That's how we call it. So if you want to blast the bench 88, and you just draw the 8 meters, just the 8 meters. You don't add any subdraw. So that means you draw up to the toe line, then you blast. Okay, you blast. Mind you, you won't get everything to be, you won't get the level to be flat, to be even. Okay, some parts will be undulating. So it will be undulating. Okay, I don't know how to do it, but in the floor, after blasting, the floor will be undulating. You get undulating surface. So if assuming you get a toe, okay, so that hope you all know toe. Do you know toe? Toe. There are two meanings of toe. We have the toe of a bench, as we know the crest and toe. And also we have toe, the same spelling, but um when the first toe is the normal toe that we know, the crest and toe, and the same spelling toe is when you blast. Okay, so let me use this one as the floor, 88 floor. So you blast and you don't get even surface. So you get some surface, some part of the surface to be up like this. Okay, so this one is called toe. The level of the surface that is up. So let's assume this one is 1 meter. The floor that you are expecting to get, you get some part to be 1 meters up. Okay, so this one too is called toe. So when I mention toe, I don't mean just the toe, the bench, but toe as in after blast. after blast toe, when you don't get a level surface. So the part of the surface that is up is the toe. Okay. So let's say after blasting this 8 meter and you get some part to be 1 meter up. This one, you cannot, it will be difficult to treat this one. Okay. Unless maybe you add it to the next bench when you are coming to drill the next bench. Instead of drilling 8 meter at that particular section, you will make it 9 meters to cater for the toe that was up. All right. But when you use the sub draw, so assuming this, you didn't draw just the 8 meters, you added 1.5 meter sub draw. Okay. So instead of 8, you will draw 9.5. And after that, the floor, you get the toe within the sub draw level. Because this is not part of the 1.5 is just the sub draw to level the surface. You are still gotten your 8 meter that you wanted. So you just use the other blasted section of the sub draw to level the surface. So you can use that to level the surface. So it will cover the toe. So that at the end you get your level surface. Please, are you okay? While we add the sub draw. So it will help you to level the surface. Okay. It can help to minimize the toes. Can help to minimize the toes. Okay. And when assuming the next bench that you draw, you have assuming after blasting the 8 bench, the next bench that you will draw, you have to leave a berm. Okay, that one, some portion of the bench that will fall within the berm, will fall on the berm. You don't have to add the sub draw. Okay, let me come again. What I'm trying to say is that if this is the bench, okay, the bench that you are blasting. This is the bench that you are blasting. And after blasting this bench, you draw on the next bench, right? The next level. After blasting and mining this off, you draw on the next surface. And if the next surface you want to leave a berm, okay, let's say you want to leave some 7 meters berm. So what I'm saying is that in such an instance, you don't have to use sub draw at the section of the bench that falls on where you would like to leave the berm. Why do you think we shouldn't use the sub draw? The reason why you don't have to use the sub draw is that when you put the sub draw, it might go into the berm. Okay. For berm, we know the berm, we leave the berm for stability reasons. Okay, and also to catch falling rocks. That's why we hope you know berm. You know berm, right? The berm is for stability reason and also to catch falling rocks. So at any things, you don't want to alter the berm. So you don't have to leave the sub draw there so that when the sub draw 1.5 might go into the berm. So in that case, it will alter the berm. And when you alter the berm, you can't switch it back. Okay. When you alter the berm, you have altered it. It can't be changed. In that case, where that the parts of the bench that will fall on the berm, you won't leave sub draw. So for this particular bench, if you were drilling and the plan was to leave a berm on the next bench. So this side of the bench, the holes there, we wouldn't have added any sub draw. So we just draw the 8 meters. You don't want to alter the berm there. But the other sections, like this section where you don't have any berm, you can add the sub draw. Okay, 1.5, 1.5 because there is no berm there. So even when it goes in, we know at the end we are coming to mine that part off. Okay, so that's what I wanted to see. And the bench height. So the bench height, we know it already. The distance between the press and the toe of the bench is the bench height.